Does anything come out of a black hole? The question itself could be interpreted in various different ways, the most obvious interpretation being, do black holes lead anywhere? Or can one enter a black hole and come out somewhere else, like the idea of a wormhole? This would be likened to a one-way digestive system, the hole itself being the mouth, and unfortunately, there is no evidence to suggest that this happens. All evidence points to the center of a black hole, beyond the event horizon, being hypercondensed matter. After all, a black hole is a point at which matter has been so thoroughly condensed that its gravity becomes an inescapable force. What enters a black hole is simply added to that condensed matter, though some speculate that the condensed matter at the center of the black hole contains extremely heavy undiscovered elements. Not much else is known about what lies beyond the event horizon. The more matter that is condensed, the more gravity the black hole has, and the harder it is for things to escape that gravity. However, things do come out of black holes. It's just not in the traditional beginning-end continuity that one imagines. For something to exit a black hole, it simply leaves through the entrance, more like a two-way digestive system. However, the center of a black hole has the greatest gravitational force of anything else in the universe, so it is very difficult, rare, and under very specific circumstances that anything ever comes out. For the overwhelming gravity of a black hole to be overcome, the amount of matter and energy in the system must be unthinkable. This only occurs in one phenomenon, the most powerful, terrifying, perspective-shifting force of destruction in the known universe, the gamma-ray burst. Black holes, unsurprisingly, are involved with more than one kind of devastatingly destructive stellar event. The birth of a black hole occurs when the core of a supermassive star runs out of fuel. The energy of fusion in the star's core is no longer pushing outward against the gravity of the star, and it collapses in on itself. Without the outward pressure generated by fusion, the collapsing massive star becomes more and more dense, its gravity increasing the more dense it becomes. This, in essence, is how a black hole is created. There are variations. This can lead to a supernova, where the collapse of the star's core is so violent that the outer layers of star matter are expelled outward by gravitational potential energy in a grand explosion. It can also lead to an unnova, or failed supernova, in which the collapsing star's gravity is powerful enough to absorb the energy of the supernova. However, the most spectacular and energetic result of the formation of a black hole occurs when the core of an old, hypermassive star with low metal content and high rate of rotation collapses. When this happens, material outside the collapsing core spins inward at extremely high velocities, forming an accretion disk of incredibly high density. As this rotating disk is consumed by the newly formed black hole, currents, or jets, form along the rotational axis of the hole. These jets contain matter that is far less dense than the matter found in the disk, and this matter is accelerated to extreme velocities, nearing the speed of light. The matter is expelled from the core and through the outer layers of the collapsing star. As it gets closer to the surface of the star, this matter jet can actually increase in velocity because it has less resistance. When the matter jet erupts from the surface of the collapsing star, it can be traveling at velocities that are remarkably close to the speed of light, having a Lorentz factor of 100 or greater. Most of the matter jet's energy, however, is released in the form of something even more dangerous: gamma radiation. Gamma rays ionize and they destroy biological matter. They can penetrate most anything, and when they travel through living tissue, this can destroy cells and denature or even mutate DNA. In 2008, the SWIFT satellite detected gamma-ray burst GRB 080319b. The energy output of this particular gamma-ray burst was calculated to be comparable to, possibly greater than, the total latent energy of our Sun. The farthest observed distance traveled by a gamma-ray burst was GRB 090423, which traveled 13 billion light-years. It is easy to see why the gamma-ray burst is classified as the most destructive force known in the universe. In fact, there is evidence to suggest that close contact with one such burst has caused a mass extinction on Earth in the past, known as the Ordovician extinction event, the first of the Big Five mass extinctions occurring 440 million years ago. Scientists have stated that until 5 billion years ago, galaxies were so small that gamma-ray bursts would always have been close enough to destroy any life that could have been developing. This means that until 5 billion years ago, gamma-ray bursts made the development of life impossible. It has even been suggested that because of the catastrophic effects of gamma-ray bursts, life can only safely develop in small parts of the universe. In theory, as few as 10% of galaxies are safe. Thankfully, as destructive as gamma-ray bursts are, they are very uncommon, especially in galaxies like the Milky Way, which are rich in heavy elements. If a gamma-ray burst from outside of the galaxy were to hit Earth, our atmosphere would most likely shield us from most of the impact. However, in 2018, the tertiary star system known as Apep was detected, located within the Milky Way galaxy, just 8,000 light-years away from Earth. This star system, named after the Egyptian serpent deity Apophis, the antithesis of the sun god Ra, generates solar winds that spin at 7.5 million miles per hour, so fast that it has whipped up a thick cloud of dust called a pinwheel nebula. The speed of these stellar winds suggests that these stars are near critical rotation, the point at which the stars will rotate so fast that they rip themselves apart. Within a cosmological blink of an eye, the supermassive stars in the Apep system will collapse. Either they will form neutron stars and collide to form a black hole, or some combination of one star collapsing will lead to instability and collapse in the other, leading to the same end. Either way, because of the extreme velocity at which the system is rotating, it is widely theorized by astronomers and astrophysicists that the collapse of the system will result in a gamma-ray burst. A dense accretion disk will form around the newly created black hole, spinning fast into the gravitational field, creating less dense matter jets, which will be propelled outward, erupting from the collapsing system, and releasing energy equivalent to hundreds of trillions of nuclear bombs, going off every second for 1 billion years. What's more, scientists have determined that the burst produced by the Apep system would be a long sustained one, potentially lasting for hours. Were a gamma-ray burst to collide with a planet from a very short distance, like 1 astronomical unit, any life on the planet would be vaporized nearly instantaneously. However, if the Apep system gamma-ray burst were to hit the Earth, we would not suffer such a lucky fate. From 8,000 light-years away, a gamma-ray burst would likely devastate our ozone layer, which would bear the brunt of the cataclysmic force as it would absorb most of the gamma rays before they could reach the Earth. The radiation that made it to the planet would kill microbes and other small organisms, likely causing serious genetic damage or mutation to larger organisms. However, the most devastating effect would come from the damage done to the atmosphere. The gamma radiation would break up nitrogenous and oxygenous molecules in the atmosphere, leaving behind nitrogen oxides such as nitrogen dioxide. Nitrogen oxides would not only block out most of the Earth's sunlight, but it would also severely damage the ozone layer. An extreme overdose of ultraviolet radiation due to the lack of ozone would continue to devastate organisms. The noxious clouds of oxides blotting out the sun could lead to the death of terrestrial plant life. This would lead to a slow, cold, agonizing death for those of us unfortunate enough to inhabit the Earth. Though the geological blink of an eye that it will take for the Apep system to collapse could be thousands or hundreds of thousands of years, the predictions are not exact. Apep, like the serpent god of chaos and disorder after which it was named, is unpredictable. In the event that the Earth finds itself in the firing line of a gamma-ray burst, one can only hope that it is either far enough away that it isn't a threat, or close enough to make the destruction of everything that we know and hold dear quick and painless. Were the Earth unfortunate enough to find itself in the nightmare inverse Goldilocks zone, directly hit by the Apep system gamma-ray burst, the rest of its days would be dark, cold, and utterly horrifying. the universe would not shed a tear as the life that distinguished our planet from the rest of the cosmos wasted away. All of the great achievements of mankind through hundreds of thousands of years of progress, torn asunder by chaos, in a smothering haze of radiation and toxic clouds, the will of the serpent god Apophis, done. Thank you for watching and listening. If you like this video and you'd like to see more like it, please subscribe to my YouTube channel, like, and share the video. And if you'd like to support the channel in a more direct way, you can donate to my Patreon or pick up some merch from my Represent.com merch store. Links should be on screen and also in the description down below.